address lines. It has got 14 general purpose, 14 registers, okay, and 2 units, bus interface unit and execution unit. In bus interface unit, you have segment register, code segment, data segment, extra segment, stack segment, and instruction pointer, okay. And in execution unit, you have general purpose register, AX, BX, CX. You can use AX if you want to do 8-bit operation, AH, AL, BH, BL, CH, CL, okay. H represent higher order, L represent lower order. And you had 2 index register, source index, destination index, and 2 pointers like source pointer and destination pointer. And special register, flag register you had. So totally how many flags? Totally how many flags? You can hear my voice?
It's not.
How many flags totally? 9 flags. Okay, sign, parity, auxiliary carry, then 0 flag. Okay, then other flags like direction, trap, overflows are there. Okay, so this is what we have seen, and how to calculate the 20-bit physical address also we saw. Okay, how to calculate the 20-bit physical address? Segment register address 16-bit. Add append 0, 4 zeros, so you will get 20 bits. Along with that, you have to add the offset address. Okay, segment address, append 4 zeros, you will get 20 bits, plus offset address will give you the physical address, location where your instruction or data is present. Okay, so this is what we have seen. Today we will see about the instruction set of 8086. Okay, every processor has got an format, right, in how to write, right? See, high level C, C++, Java, Python we are studying. So it is it's like platform independent, right? It's not closely depending upon what type of processor you are doing, right? So you can learn Python, you can learn program irrespective of the processor. You can run the program. Okay. So whereas in earlier time, we have been writing program using assembly level language. So assembly level language means every processor will be given a manual. You have to study that, their instructions, how to write the instructions there, right? So that is what we are going to see. See, normally, I'll share the slides. Okay. See here. See, if they ask what is instruction means, it is nothing but it is a specific function or task given to a processor. Okay, that is called an instruction. Group of instruction is called as an instruction set. Okay, you have more than 20,000 instruction as it is stated, but you're not going to study all the 20,000. And these instructions are grouped into 6 groups depending on the functions they are going to perform. Okay, so you are also having MPMC lab. So in lab, what common instructions you will be using for writing program, we will see. Okay, because all 20,000 it is not necessary. Very frequently used instructions we will see in each group. Okay, so first one is data transfer instruction. Next is arithmetic instruction, bit manipulation instruction, program execution, string instruction, and process control. Okay, so data transfer. Okay, what do you mean by data transfer? From where to where you can transfer the data, that is there, right? So if you have a system, processor is there, input device, output device, memory. Okay, this is the actual setup of any system. Okay. So data you can transfer from where to where. So data can be present in the input device. It can be present in your memory. Okay, so transfer means from processor, inside the processor you are having registers. Okay, so from where to where the data can be transferred? From processor to memory, memory to processor, one thing. Second thing, from input device to your processor. Otherwise, from processor, you can send some information to the output device for display. For example, if you want to display some content, processor to output device. If you want to read from the keyboard to processor. Okay. If you want to execute your program, from the memory, it will read an instruction, processor will read it. So data can be transferred from processor to memory, memory to processor. Otherwise, it's input and output device. This is the setup. Okay. So which instruction you can use for data transfer? Okay. Common instruction. There is an instruction. See here, this is what is given. See here, data can be transferred from source to destination. Which is source? Processor is source. Destination is memory. Okay. Memory, from memory to processor, if you want to transfer, memory is the source, processor is the destination. Okay. From input output device, if you want to transfer, means you should know the IO device port address. Okay. So in the instruction, you will specify the memory address. You can also specify the port address, because your processor will go to that particular port where your input or output device is connected, and from there it will read the data. Okay, this is the normal thing what is happening. So which instruction is commonly used is memory to processor data transfer. Okay, instruction move. See this instruction, move DS, SRC. DS means destination register, right? SRC means source register. This is a common thing, right? One more thing, register to register data transfer is also allowed within your processor. I have content like 25 in A register, AX register. I want to move this content to CX register. So register to register also I can transfer the data. Okay. Register to register is allowed, but constraint, memory to memory data transfer is not allowed. From one location of memory, directly you cannot transfer a data to the other location. Okay. So how means, first from memory to processor you have to get register, and from register again it will move to the memory. So memory to memory data transfer is not allowed. Okay, that is the concept. See the first one. See this instruction, move instruction. Okay. So any instruction, if you say take, it has got two parts. First is opcode, second followed by operand. Opcode will specify what operation the instruction has to do, and operand is where you are going to have your data or memory location. Any instructions, maximum how many operand your 8086 is having is 2 operand instruction. We have instructions like maximum 2 operand it can have. Then 1 operand instruction is there. Then you need 0 operand. If you don't specify the operand at all, also I'll tell you how, right? So maximum 2. That means destination, SRC. Okay. Example. See this example. One example. If I tell other slide will be easy. Okay. See when I give an example, what I can do is see the first one, move CX, 037A. Okay, 037A is 16-bit data, hexadecimal value. That is the reason I am putting H here. H represents hexadecimal value. One thing. Move instruction, what it does is, it copies the value 037A to your destination register CX. Okay. So after the execution of this instruction, if you see the content of CX, you will be having there 037A. That is the move. That this data is transferred to your CX register. Okay. Here the data is present in the instruction itself. So it is called immediate. Like for example, it's an immediate. Is it clear? See the next one. Move AL, BL. So here the data transfer is between mean one register is having is my voice audible?
Yes, ma'am.
Yes, ma'am.
Okay. The second example, data is transferred from one array. For example, AL is having 1, BL is having 2. I am executing this instruction. So what will happen now? What will happen? See what this instruction will do. See, nobody are there in the group. Meet. Harsha?
Transfers data, ma'am.
So what will be the value? Simple thing, move AL, BL. So which is source, which is destination? Source register is BL. Destination register is AL. So what this instruction will do? It will transfer the data from BL to AL. So BL is having 2. That 2 value will be copied to your AL. That's it. So after the execution, if you see the register of AL, what will be the value? 2. That's all, It's a simple data transfer. Okay. So from one register, what data is there, you are transferring to other register. That's all. Is it clear? Similarly, first one means what? Already the data in the instruction itself is specified. That data will be moved to that register. Is it clear, everyone? Move means data transfer. One of the data transfer used. Is it clear, everyone?
Yes, ma'am.
Okay. See the third one. Third one only is very, very important. What is the difference between the first and the third one? You can tell it is a simple bracket. Is it not? But what is a very important thing, I'll tell you. First instruction, data is present in the instruction. Second instruction, move AL, BL. From one register, you're transferring the data to the other register. Third option is where? Memory location. If I want to transfer data from memory location to the register BX, I can use this, right? So how I have to write is, see here 0301 H, and I am putting a square bracket. What is the meaning of this is, here 0301 is not data, it is the address of the memory location. In this memory location, for example, I am having data 10. That value will be transferred to your BX register. Is it clear, everyone? When I put square bracket, it is a meaning, it is the address of the memory location. Okay. So first case, second case and all, within processor itself it is happening. Third example, data transfer from memory location to the register which is present in the processor. Okay. In that case, a small difference is you have to put a square bracket. Square bracket means the value inside the square bracket will represent the address of the memory location. Okay. Now, from this address memory location, the data present is 10. That value will be moved to your BX register. Is it clear, everyone?
Yes, ma'am.
Why, who told yes now?
Madan Raj, ma'am.
Okay, okay. Others are not here, huh? Girls, what you people are doing, I don't know. Girls? Girls representative? means girls represented Aarti, huh? Harsha,
Yes, ma'am.
why everyone are keeping quiet? Are they on the meet?
Yes, ma'am.
They are.
What girls, what you people are doing? Only Harsha will answer or Madan or some few, huh? Why girls can't answer, huh? If you tell some feedback or something only, I will know whether you are in the meet, you are listening, right? Girls only should answer now. At least you tell yes. Okay, this is data transfer. Data transfer from processor to memory. Okay, this this instruction commonly you will use for writing your program. Okay, if you see a program, you can understand. Okay, other instruction. See the previous instruction, move instruction, two operand. Like see here, move AL comma BL. AL is one operand, BL is the second operand. Similarly, move BX comma 0301 means BX is one operand and next is the second operand. Okay, and see the next data transfer instruction, push and pop. Okay, so this instruction is commonly used for stack operation. When you want to read from the top of the stack, which is pointed by a stack pointer. Similarly, when you want to write or read, right, you can use push or the pop. Push means you can write into the top of the stack. Pop means you can read, right? Processor will read from the stack. Okay, so here means from stack to your processor, you are transferring your data. See the data format is push operand. Here how many operand instruction it is? One operand. See the example, push BX. Similarly pop AX. Okay, only one operand, BX is specified. Okay, so push BX if I give, what is the meaning? Push instruction will transfer the data which is present in BX to the top of the stack. For that, you will be using a stack pointer for pointing to the stack of the top of the stack. Similarly, if I want to read from the stack means, see that is pop AX. Pop, right? I want to read. So what this instruction will do? Stack pointer will point to the top of the stack, and from there whatever data is there, it will be transferred to your AX register. Okay, so processor to stack operation, you will be using push and pop instruction. Okay, move instruction is general from processor to memory, register to register, and for immediate addressing you will be using the move instructions. Okay, these all are the instructions you will be using commonly. And next instruction is exchange. XCHG, exchange, DX, SRC. See, suppose I am asking you to write a program to swap the content of two registers or two variables, swapping program. So what you will do? You will take one temporary register or temporary location. You will move the content, and after that you will try to swap. Right? It will take 2-3 lines. Right? In assembly also it will take 2 instructions, 3 instructions. In order to avoid that, you have a direct instruction called exchange. DX, the content of DX is 10. The content of AX is 20. I am executing this instruction. After the execution of this instruction, if you see the value What will be the value of dx and ax? Girls? Benipriya? Bollu Geeta? Charumati?
Yes, ma'am.
What will be the value?
We are going to swap AX and DX, la, ma'am.
Hmm.
So AX is 10 and DX is 11, la, ma'am. 20.
11? Swap means what will happen?
Yes, ma'am. 20, ma'am.
After the execution, if you see the register AX, in AX 20 will be, and in, DX comma AX, no? So after execution, DX will have 20 and AX will have 20. Just swapping, that's all. Okay?
Okay, ma'am.
What Benipriya and Geeta is doing?
I don't know, ma'am.
They are not there. I'll put absent only, okay? Divya?
Yes, ma'am.
Okay. Janavi? Jivita? Kanimori?
Yes, ma'am.
Kavita?
Yes, ma'am.
Kirtana? Monica?
Yes, ma'am.
Niveta?
Yes, ma'am.
Divya?
Yes, ma'am.
Akshaya?
Yes, ma'am.
Aarti?
Yes, ma'am.
Adi Lakshmi?
Yes, ma'am.
Okay. Is it clear with the exchange instruction?
Yes, ma'am.
Okay. Data transfer, this main instruction. After that, we'll continue in the next class. Okay. Now, I told you data transfer between processor and memory, register to register data transfer, we saw, and stack to processor, processor to stack, we have seen, push and pop instruction, and move instruction, and exchange means swapping. Okay. Now, data can be transferred from input device to your processor, or processor to your output device, right? Suppose you enter a content in a keyboard, right? That content should reach your processor. So processor has to read what you have typed. Similarly, after computation, if the processor wants to display the value, so it has to give the value to the output device, which is connected to the output port. Okay. So in the instruction, you have to specify the port address. Okay. High-level language, writing high-level language is flexible. You need not know what is the port address, where your devices are connected, what is the driver address, you need not know, right? Nothing you know, right? You know only how to, the structure of that program, etc., right? So here, in assembly level language, see the instruction. This is also two operand instruction, in and chance